Hi folks, this week's lessons are going to focus on intersections. So let's talk a little bit about what you did with intersections back in grades 9 and 10. Okay, so let's say in grade 9 you might have had one line representing the distance of one person walking away from their home, and then the other one representing the distance of somebody walking towards that person's home. Okay, and the point of intersection would have represented the moment in time in which they meet. They're the same distance away. Okay, or it could have been a cost question. Okay, so you have, the cost of a gathering, depending on the number of people, might be given by this line here, and then you might have another hall that's charging more to rent the hall itself, but then less per person. And at a particular number of people, they charge the same amount. So depending on how many you're going to be, you're going to choose one over the other. Or you could have solved geometry problems. Okay, and in grade 10, you might have had three lines that intersect. And of course, when you look at their intersection, what do they form? They form a triangle. Okay, and this allows you to do analytic geometry. Okay, but essentially what you found was that when you looked at these questions algebraically, what is essentially a geometric problem, at least originally this idea of finding points of intersections of lines on the Cartesian plane, allowed you to solve a lot of questions that had nothing to do with geometry. Okay, you could use a system of equations to figure out how much of each type of alcohol to put in a solution to get a particular concentration, or how much money you should be investing in each type of account to make a certain amount of interest at the end of the year. Okay, and this is what we're going to do now, is we're going to start with some analytic geometry in 3D, but we're going to see as we get towards the end of the course that similarly, the tools that we learn from doing these analytic geometry problems are going to be useful to determine other types of problems. So it'd actually be good if you stop the video in about a minute to take a bit of time to see if you can figure these out yourself. So we're going to work on this week is we're going to talk about intersections of lines. Okay, so take a couple of pencils or a couple of pens and try to figure out what are all the ways lines can interact with each other in 3D now. So you're not in 2D anymore, you're in 3D. Okay, the next thing we're going to look at is we're going to bring that other object that we recently defined, the plane. What about a line and a plane? How might they intersect or not intersect? And lastly, we're going to take a look at two planes. So try to figure out how two planes might or might not intersect. All right, so ideally you're stopping the video now, taking a couple of minutes to figure out all the possibilities, and then we'll come back and take a look at them. Okay. Okay, so we're back. So let's take a look at our three different problems. So let's take the idea of two lines. So we know that in 2D, lines can either be parallel and distinct, parallel and collinear, so essentially the same line, or they could intersect at one point. And when you think about it in 3D, you can have the same thing. You could have two lines that are parallel and distinct. Okay, so they're parallel, but they never meet. Okay, they could be parallel and collinear. Essentially, the equations represent the exact same line. You can have two lines that intersect at a single point. Okay, so first thing I notice here is they're not parallel anymore. But this is where we have a different scenario in 3D that did not exist in 2D. You could have two lines that are not parallel, yet they don't ever intersect. Okay, so you can imagine that you can now have two lines. So this one is actually below, even though from there it might look like they intersect, they never actually intersect. All right, and this is what we call skew lines. Okay, so interesting that in 3D, we have an extra scenario. All right, so let's take a look at a line and a plane. Now, again, we talked about the plane, say in 3D, why might we look at it? Say it represents the motion of the planets around the sun, and you've got some meteor that's coming in towards this plane. You might want to determine where it intersects. And when it intersects, you want to make sure the Earth, or in fact any other planet, doesn't happen to be there. Otherwise, you've got some big preparations to do. So these are the types of geometric problems that we want to solve using things like lines and planes. So there you go. Clearly, a line can intersect a plane exactly once. Now notice here that this line, this plane, are not parallel to each other. What if the line and the plane were parallel to each other? Well, again, you can have a scenario where the line and the plane are parallel and distinct, meaning they're never going to intersect, and you can see that the line and the plane are parallel. Okay? And of course, another scenario where the line and plane are parallel is if the line is on the plane. Okay? In which case there's infinitely many points of intersection. Essentially, all the points on the line intersect with the plane. Okay? So let's take a look at the last example, which is two planes. So, I mean, again, I can imagine that you could have two planes that are parallel and distinct. All right? Never intersect. You could have two planes, two equations that represent the exact same plane. Okay, so we say that they're coincident. Okay, they represent the same plane. But this is one thing that if you try to figure out, can they ever intersect in a point? And you probably realize that there's no way for them to intersect in a point. Even if you try to do something like this and say, oh, they intersect at the point. Remember, this piece of cardboard just represents a portion of the plane. It continues on in all directions. So two planes can never intersect in just a point. They do intersect, though, in a line. So you see that if these two planes, if they're not parallel to each other, they're going to intersect in a line. So when you're looking for the intersection between these two, if they're not parallel, keep in mind that we're going to be looking for the equation of a line. Okay, so in the next two videos, we're just going to go through some examples as to how we can do this algebraically to determine whether or not there is an intersection, and if there is, determine either the point or the equation that represents that intersection. All right, that's it for this part.